they have set the goal of achieving about more than 10% of the green loans out there. And right now it's only 4% out of their loan portfolio. And the reason is they get fundings from EBRD, GCF, and all the big funds, and they give them a different checklists, like rubrics of like choosing the right projects. But none of them is translated on the ground to actionable and local projects. And it's a different standard trying to be for any different groundings. So all these put together, what we are trying to solve at point is we put all the financial data. I think it was a nice segue from the Austin's speech that there are so many different layers of data. The local data that people, governments have their own knowledge, and then there's also satellite data. There's open data everybody can access. There are commercial data, companies and as well as project developers hold on to it. And on top of that, there's the solver data. So what we do is we take all these messy data, synthesize it, turn it into one very simple, investable, investor-grade memos. So it makes it easier for DFIs and as well as the funds to understand what does it mean, what kind of impact is going to bring their dollars in emerging markets like Mongolia. So that is the mechanism that we're building. And it really came from the hard way, like I said. We tried to be project developers ourselves. So one particular example why we think data matters the most is that our project, we are a reforestation project in the northwestern part of Mongolia, and it took us 18 months to have the PDD going. And even the experts, like global experts, they couldn't access because different languages, the field notes, and then all the data of either the rangers, like handwritten notes, or the local nomads, their own knowledge. And on top of that, different languages. For example, calculated biomass of the local species. Out of 5, they could only find 2, and most of them were in different languages. And all these, data fragmentation really slowed down all the due diligence processes. And on top of that, like earlier we were saying, they start hiring consultants, and consultants only talk to the certain data points. They never actually go deep down to those who are the most effective. So we think through technology, specifically the Web3, and then as well as the AI, we definitely can include those who are the most affected by the climate change and have a say in it, how the financing would be implemented in a way that honors their local culture, biodiversity, and then their own way of living. That is where we're building with them, and then we have our own first sovereign pilot test going on with Mongolia. It's 1,000 hectares of a reforestation project, and right now we're synthesizing all the data that we have. European Union's Copernicus, we are using it, as well as putting together, organizing, filtering, and all the data in one place. But it doesn't end there, and very similar to what Austin said, we actually incentivize the accuracy and quality of the data. Everybody has a say in it. There is a sovereign lot, and there is a local lot, and there is a commercial lot. All the data is valuable, but we don't take it all. And as you already know, what you feed to AI is very important. If you feed it bad data, brings a bad outcome, and then the decision becomes wrong. So in order to make sure to vet what's going into this natural language processing algorithm is very important, and that is why we vet the data. And very similarly, we use incentive mechanism, and some nodes can even challenge certain data. Okay, what you provided about the flooding or biodiversity loss, or maybe the fire is not accurate. Then we double check it throughout all the nodes, and as long as the data is about 80% accuracy, it passes into the engine, which generates more intelligent and easier local and organic memo to investors. So it actually cuts the process from 18 months to 2 to 3 months. And it makes it way cheaper for development or any other institutions to deploy capital with actual real data with the language that we understand. So that is, we call it climate intelligence as a service. It's like CIAS, like a SaaS, and that's what we're building. And we think sovereign AI, and on top of it, specifically the bioregional data is super important. And when you say Mongolia, everybody thinks it's very isolated, but actually, when you look at the bioregional ecosystem, it comes polluted with the entire Central Asia region. So instead of trying project by project, let's create a portfolio of a better, good quality portfolio for investors to create. And all the sovereign data are there, but they are interoperable to solve certain bioregional challenges. So that's what we've been working, and there are, again, significantly two layers. One is on the blockchain, verifying the data authentic mechanism, and then the later part is on the climate specific natural language processing algorithm. And then we make it interactive, easy with the data. So these two, since we have data from the entry points as well as from the funders, we can start creating these simulation models. Because our algorithm starts to learn the patterns. What does it take? What's data? How long does it take? What requirements need for certain projects like reforestation or soil restoration, or perhaps maybe marine restoration, right? For these, it started to create this kind of data. So which was exciting to see. For the land use information, we couldn't find it, and yet we were able to trace it back to the, using a different set of data to figure justify this land was only used for the basic, for example. So I think it's important to address those data quality assurances like customers working on, and then also the UX side, making it easy for people. Earlier, our colleagues were talking about making it easy, gamified, easy to use. But in the end, really, we're trying to unlock that, big funds and then local projects in order to meet the quality, local, real data that an engine that is emphasized translating them into each other. So there's no more